Hello everyone. Today let us take up the next programming example, a simulation programming example in NS2. Here is the problem statement. It goes like this. So wherein a network should have the 4 nodes. Let me divide the problem at the same time. So here the network should have the 4 nodes, and those nodes should be named as N0, N1, N2 and N3. And among this, N0 should act as FTP source, wherein N1 should act as the telnet source, and N2 should act as the intermediate router, and N3 is a common destination for both. And here in the next part of the question says that you will have to connect them by using the duplex links, and what is the capacity of each link, such as N0 and N2 should be connected with the bandwidth of 5 Mbps with the delay as 10 milliseconds, and N1 and N2 should be connected with the 10 Mbps of bandwidth and 10 milliseconds of delay, and finally N2 and N3 should be connected with the 15 Mbps of bandwidth and 10 milliseconds of delay. Then we will have to create the TCP agents, wherein TCP agent should be connected with the N0 and N1 because both will be acting as a source node, and the sync agent should be attached with the N3 because that will be acting as a destination. Then for the communication, packet size should be defined as the 500 megabytes, wherein the time interval should be as 0.001 seconds, and the maximum size of the packet can generate a size of 1 KB of data. Finally, last part of the question says that both FTP and TELNET should start at the 0.3 seconds and they have to end at the 5 seconds. So for that we need to generate the TCL script and observe the output with the trace files. So here let me define somewhat here as first of all, remember I should have the 4 nodes. Let me take up as an example here. So I'll consider this as a destination, this as intermediator, and these are the 2 source nodes. So what is this? It is the N0. I'll call it as N0, and this is what? N1, and this is the N2, and this is N3. Yeah. So now like this I have totally 4 nodes. I have 4 nodes. Then among this N0, let me call this as a FTP source, because this is the FTP source. Let me call this as FTP source, and this is a telnet source. These are the 2 source nodes. So this is what the FTP source, and this is the telnet source, and this is the common destination. This is the common destination node. Then so I'll call it as a simply destination, whereas this is the intermediate router. This is the intermediate router. Then I need to connect these nodes such a way that, so understand, I need to connect these nodes. So I need to connect N0 to the N2, and I should connect the nodes, which are all the nodes, which is N1 and N2, and finally I should connect the N2 and N3. Like this I should have the 3 links. See, this is where it is given 3 links should be there. What is the capacity of N0 and N2? This is what it is, 5 Mbps of delay and 10 milliseconds of 5 Mbps of bandwidth and 10 milliseconds of delay. That's the capacity of this link. What about the N1 to N2? What about the N1 and N2? It is 10 megabits of bandwidth and 10 milliseconds of delay. And finally for the link between N1 and N3, it is 15 Mbps of bandwidth and 10 milliseconds of delay. So then it is very clear that there are 2 sources and the common destination with the 1 intermediate node with the different bandwidth and the delay. So it is also given what is the size of the packet just to be fixed, and what is the time interval. So for this, let us generate the TCL script. So for generating the TCL script, as usual, let me make use of the Fedora. So here let me make use of Fedora to run my NS2 TCL script. So on here let me create the file, as this is my third example which I am taking up. So I'll call this as a 3.tcl, the third program.tcl. And this is now let's first and foremost thing, let us declare the simulator. So I'll define the simulator. I'll say that simulator define. I'm going to say definition. So I'll need to declare the simulator. So this is where, so what I supposed to do, I just need to create the ns as a pointer. So by using set ns, so set ns, what is supposed to do, new simulator, call the simulator class file, then set trf, which is a pointer to the trace file. I'll say it as open, as my source file name is 3, so I'll call this as a 3.tr, and I'm opening that with the write mode. So then I need to connect that. That's what, by making use of, for this, under this pointer ns, so trace all, and what is to be traced, it is whatever it is pointed by the trf. Then so I need to create one more pointer. I'll call it as a namf, and I'll open that nam file. So here let me consider it as a 3.nam, and I'm opening with the write mode only. So again as usual, I need to execute that. That's what, trace all namf. So what namf? It is the $namf. So here also you remember, because this is the pointer, so I should make use of $trf, so that you just make a change. Now then so that's what, end of the defining the simulator. Now let us start creating the nodes. I'll say it as create nodes. So under the create nodes, so how many nodes I need to have? Totally 4 nodes I should have. I'll call it as n0, and under which it is under the ns, so just a node. Okay, so the same I need to use it for 4 nodes. So remember, I need 4 nodes, so n1, n2 and n3. So I'm done with the creating the nodes. Now let me label them. So labeling, I call it as labeling. So by using the label as $n0, let me label the n0 as what? So based on our example, it is the FTP source. That is FTP source, wherein $n1 is what? Label. I'll say it as telnet source. So then what about n2? It is $n2, just the intermediate router. Then finally n3 as what? I'll say it as a common destination. That's the common destination for both the source nodes. So I'm done with the labeling. Now let us connect them. So I'll say that connectivity, I'll say linking. So that I will do by making use of, that's what, by making use of duplex links. So $ns, so which link? It is a duplex link. Between what? It is between the first n0 to n2, n0 to the n2. And if you remembered, so because you can remember, you can also make a point of it. So these are the things between n0 and n2. It is the 5 Mbps and 10 milliseconds, and this is 10 and 15. So that you can just keep in mind. So in the same way, based on that itself, I'll set as 5 MB of bandwidth and 10 milliseconds of delay, and as usual drop tail mechanism. So that's what between n0 and n2. So what about let's think about the next links, which is between N1 and N2. In case between N1 and N2, if you remember, it is what, 10 Mbps and 10 millisecond itself, where in the last one it is between N2 and N3, it was 15 Mbps. So that's how I'm done. I'm just done with the connectivity. That's what, by using the my duplex links. Then now I need to create the agents. So I'll say that agent creation. So as I'll need to, so remember one thing. So based on my problem here, it is said that you will have to apply the FTP and TELNET applications. But one thing is for sure, remember the FTP and TELNET both are means of connection oriented services, or both will provide the connection oriented service. So as they will provide the connection oriented service, so I can say that both are the application under the TCP itself. So only I just need to create the TCP agent itself for the purpose of both the FTP and the TELNET. Even when you say that both are a means of TCP service, which is a connection oriented service, even then what is the major difference you can find between the FTP and the TELNET? In the sense, remember the little difference is something like FTP will be, it is just like a file transfer protocol, which is purely for the web browsing, or in the other way you say it as a downloading process whenever you want to share the files. Wherein the TELNET, it is a purely, which is a remote access protocol, like you can say it as a, which will be used for the chatting purpose. It's not specifically downloading, you can say it as a chatting purpose, where there is a remote access is much required with respect to TELNET, where such kind of remote login is not much required with respect to FTP. And also the ports which will be utilized with respect to FTP, where we will be utilizing the two ports, which is port number 20 and 21 in case of FTP, wherein your TELNET will make use of the port number 23. So like that, there are a few differences which exist between the FTP and TELNET. But as of now, remember both the FTP and TELNET both do provide a connection oriented service itself. So for that you do require the TCP agent itself. So in such scenario, here I may be wishing to create the FTP and TELNET service. So the what agent I should make use, in the sense, remember it is the TCP agent itself, it is not the UDP agent. So let me create a TCP agent. So for as I have the two services, two applications, which is that it is FTP and the TELNET services. So for as I have two application services, so I should have the two TCP agents. So as I need the two TCP agents, so I'll call it as a TCP1 and TCP2. So here I'm creating a TCP1. So I'll just say the TCP1 and new agent, and which agent? It is the TCP agent. It's a TCP agent. So and then I'll connect that. That's what attach agent. What I'll be attaching, I'll attach this TCP1 with the N1. N0. I'll say that TCP1. Then for this, let me create the FTP. So I'll say that set FTP for that's what new application slash FTP. So I'm creating the FTP application here, and that FTP application let me attach with the TCP1. So FTP attach agent $TCP1, because that's what I just created with the N0. Then I need to have a respective sync for this. So again, remember here, as I will be using the TCP and the FTP and TELNET, both will be using the same TCP service. So as usual, when the TCP1 will be acting as a source node, which is N0, the respective destination will be the sync. And here I need to have, as already I said, you should have the two TCP agents. One is for the FTP sender and one more for the TELNET sender. So there should be respective destination or receivers. So for that I should have the two sync agents. One is for the FTP sender and one more for the TELNET sender. So I should have the two sync agents. So as I should have the two sync agents, so let me call with the two names as sync1 and sync2. So that's the reason here I will be using a sync1. So I am just using the pointer variable as sync1. So sync1 new agent, and which agent? It is the TCP sync agent. It's a TCP sync. So then I'll connect this. That's what NS attach agent, and to which node I'll be attaching this. It is with the N3. So because the same that's what will be acting as a destination. So I'm done with the FTP case. Agent where I'll be defined with the FTP. So then now let me move on to the TCP. Let me move on to the telnet under the TCP. So I'll say that telnet. So for dealing with the telnet, so again as usual, let me create one more TCP agent. Let me call it as a TCP2 and new agent /TCP. So then I'll be connecting this NS attach agent, and I'll be attaching with the N1 now. It is a N1, and what I'll be attaching, it is the TCP2. So N1 will be acting as a TCP agent, which is the TCP sender agent. Now let me create the telnet. So set telnet new application /telnet. So new application /telnet. So then I need to connect this. That's what I'll say, telnet attach agent, and to which it is the TCP2. So I'll attach with the TCP2. Then this is what I said. This is the sync one is the respective destination for the TCP1, which is the FTP sender. Whereas in the same way I need to create one more receiver, which is a sync agent. I'll say the sync2, which is to receive from the telnet sender. TCP sync. So I hope you are following, guys. $NS attach agent, and to which I will be attaching, it is as usual N3 itself. N3, and what I am attaching, it is the sync2. So till now I am just done with the creating the agents and also the respective applications. So now let me once after this is done, now let me connect. That's what, let me say it as connecting. So here instead of I say it as here connecting, here this is not the actually connecting, because that's a logical way of creating. So I'll just say that linking by using the duplex linking. I'll say duplex linking. So this is where actually I mean to say the actual process of connectivity will happen. So I'll say that NS connect, what to connect, it is what, connect TCP1 with the sync1. In the same way, $NS connect, what will be connecting, TCP2 with the sync2. So I'm done with the connectivity. So then later I need to set the packet size. So packet size and the time interval. So time interval I am supposed to set. So let me set the packet size and the time interval. So for both FTP and telnet. So first let me set for the FTP. So FTP set packet size, remember S caps, packet size underscore space, it is 500 MB because it is given in the question. So again FTP set interval underscore is equal to 0.001, which is millisecond. Then the same way you supposed to set the same for the telnet also. So I'll say that, so instead of FTP here I'll just modify as telnet. So I'm just done with the telnet as well. Now I came to the last step. So as again as usual, in however I said in the last example as well, as we here will be dealing with the two communications. One is the TCP under the TCP communication, one is the FTP communication, one more which is the telnet communication, just to have a difference between them, just if you for differentiating between them, let us give a color to them. That's what let's differentiate them by using the colors. So first let us define the which are the colors which I is supposed to make use. So I'll just make use of the two colors. Color 1, which is by the red. Again I'll just say that color 2 as let me take up the example as green. So like that I'm just done with the two colorings, and now let us attach the colors. So let's attach those colors to watch. So I'll say that first let me take up TCP1. So which color I'll take up? Class underscore 1. So for TCP1, which is the FTP communication, I'm just giving the red color. Again let us take up TCP2, set class underscore 2. I'm just giving the green for the telnet communication, which is the second TCP communication. Then now let us define the final procedure. So last finish function, global, what are the parameters I used? NS I used, again I used TRF, again I used NAMF. Then I need to flush that. So I'll say that $NS flush trace. So I'll say flush trace. Then I need to execute them, which I am supposed to execute. It is a NAM file, and the NAM file it was I had given as 3.nam, and finally I am supposed to close everything. So I'll say close nam f, then again close trf, and exit successfully. Once after I'm done with this, I'll exit, and now I came to the last part wherein I need to start the simulation. So for that, when I supposed to start the simulation, so based on the question at point 3, I should start both FTP. I say start, again $NS at 0.03 telnet start, whereas again it is given that I is supposed to stop it NS at 5. I'll say dollar. Here also it's supposed to be dollar, remember. So $FTP stop, again $NS at 5 telnet stop. So as I'll be stopping the this telnet and the FTP's process or communication at the fifth second. Now let me stop the complete simulation by calling this finish procedure at some other time. Let me call this as 7. So at 7 second I'll be calling the finish procedure. So finally I should have the run method. So that's what I had. So first let me check it, are there any errors here? So let me compile this ns.tcl. So yeah, there are no more errors right here. Yeah, there are no more errors, but so yeah, so here it is showing us there are no errors. Even then, if you're not getting the NAM trace, which is the, if you're not getting the simulation or visualization in the sense. Let me go to the program. So there will be the problem with respect to the tracing. Yeah, this is where, so instead of nam trace I just used that as a trace, or so it's supposed to be a nam trace, because this is where, this is the nam file which is will be used for the visualization, the simulation. So now you will get it. Yes, this is what. So now you see this. So this is the FTP source, this is the telnet source, and this is the common destination. This will be the intermediate router. So let me play this. So this is what I said, the labeling is done. Now the simulation will start after the 0.3 seconds. The simulation will start after the 0.3 seconds, and this is where you can observe. So that as both telnet and FTP will be making use of the same TCP protocol, which is nothing as the connection oriented service. So there are the acknowledgement for every packet which you are transferring. It is not only for the FTP, even for the telnet also you can observe there is a green packets which are flowing back, which is acknowledgement packet. So this is the data transmission. But if one thing you can make it out from this, that this is the FTP source, and in case of telnet, so you can observe this is the size of the each data packet may vary, but wherein the maximum size is 500 MB, whereas the size of these acknowledgements are common. Either it can be to the FTP source or it can be for the telnet. So the size of the acknowledgement remains same, which will never vary, because this the common destination which is issuing the acknowledgement for both. And one more thing you can observe, there is no drop here. Either it can be from the data which is flowing from the telnet, or it can be the FTP. There is no drop which is you can observe right here, because both are using the TCP protocol itself, and you have a acknowledgement for every packet which you are transferring from through the either FTP source or it can be telnet source. So as there is a respective acknowledgement for every packet which you transfer, so there will not be any drop of the data, which is purely reliable communication. So that is the next observation you should make it out from this. And we said that after 5th second the simulation has to stop. So after the 5th second, this is the 5th second which you can observe. Right after the 5th second, this is the very important observation which you are supposed to make it out. You can observe right after the 5th second, only FTP service has stopped, whereas telnet is still happening. But in our program it is already I shown. Again I'm going to show you again. In our program we said that to stop both FTP and telnet at the 5th second itself, but you can observe from this it is only FTP has stopped at the 5th second, whereas telnet is keep going. And that's what with respect to remote login protocol, which is the telnet, once the session has started until the session has stopped, so the communication will be keep continuing. This is the which we call as a log communication, which will be keep happening with respect to telnet. Whereas FTP, once after it is logged out, so at the 5th second itself it has stopped. It is not in case of telnet. That is a major observation which is supposed to make it from this. So again as usual, so open the trace file. So I'll call it as a 3.tr. that's which I used in the program. If you want, you can check it from the program as well. So this is where I used it as a 3.tr. So let me open that gedit 3.tr. So in this, now the major observation is supposed to make it from this. It is all the TCP packet. There is nothing like FTP packet or telnet packet to differentiate. The packets will be nomenclatured here as the TCP and the acknowledgement packet for the respective TCP packet. And how to identify whether it is a FTP packet or it can be telnet packet, in the sense at any point in time, which again I repeat, there is nothing like to differentiate as a FTP packet or the telnet packet here. Only the thing that you can differentiate something like this. As see, this is the from which node to which node you are transferring. It is from the 0 to the 2. So from 0 to the 2 it is the FTP, whereas this is what 1 to the 2, which is the telnet packet. So that is what is the thing which you can differentiate. So again, as usual, you may be sending from 0 to the 2, whereas what is the actual source? It is the 0 to the 3. But for this, if you observe, For this, if you observe from 1 to the 2, whatever it is flowing, it is from 1 to the 3.1. This is the one more observation which is supposed to make it out. It is the 3.0. It is the destination node for the FTP communication. This is for the destination node for the destination address for the telnet communication. The node may be same, but the address is varying. And again, as usual, from whatever you dealt in the previous simulations as well, for every TCP packet there will be a respective acknowledgement. So if there is a TCP packet from 2 to the 3, there will be a respective acknowledgement from back 3 to the 2, and this is the time flow. And every event you can observe, there will be only 3 events which you can observe, which is the NQ, DQ, and also the receive. But at any point of time you will never see the drop. You don't see the D event here, which is you can have only the plus minus R, which is NQ, DQ, and the receive only. You will not have anything like D, which is the drop, because this is the purely a TCP service, a connection oriented service, and a purely reliable communication. And that's the first thing. Second thing is that you can see the data packet size may vary. It can be somewhere, it can be a 1040, or it can be a only 40 at the beginning somewhere. You can observe like this, but acknowledgement will be only 40 bytes. It will be always, it will be a 40 bytes only. And the sequence number and the packet IDs will be keep varying. So sequence number for the, if the sequence number for any packet is 0, then the acknowledgement will be having the 1. The packet ID will be 1. So that you need to make it out. So which is the sequence number, which is the packet ID. So that's how. So it will be keep continuing, and so you keep observing at every time there is a packet from, you can observe from 0 to the 2, and also there is a 1 to 2. That's what both the nodes are keep transferring to the 2. Then 2 will be throwing the data to the 3 as well, like this 2 to the 3 also. It should be keep flowing. But after the 5th second, I hope you remembered, right after the 5th second you will stop the FTP service. So right after the 5th second, as the FTP service will be stopped, then later there will be a telnet will be continuing, but FTP will be stopped. So that is what I want you to observe right here as so right after 5th second only the FTP communication will be stopped, whereas the TCP will be continuing, telnet will be continuing. See from here you can observe, so only there is a packet from the 1 to 2 onwards, so something like this. So there will be only 1 to 2 and 2 to 3, so that you need to make an observation, and it will be continued till the last second, which is the 7. So until you reach to the 7 seconds, so till that it will be keep happening. And the difference between these time seconds, it is the 0.001. that is what we have set in our program. It is the time interval between every packet to the packet interval. It is the 0.001 second. So that is the reason you can observe it is the difference between every second, every time interval, it is the 0.001. And these are the packet IDs and the sequence numbers which you can observe these, and these are the destination and the source nodes, and then again you have the, this is what the flow IDs. So for which flow you are talking about, if you are talking about from 0, which is source node, the FTP source, then the flow ID it is 1. If you are talking from the telnet source, then the flow ID it is automatically it is of 2. So that is what that also you can also make a difference whether the flow IDs it is 1 or 2s. So in the simulation perspective, we made the difference by setting it as a red and a green, but here you can differentiate by using this flow IDs. It is whether it is 1 1 or 2 2s. So that is what the flow IDs, and this is what the NS2 simulation with respect to this particular problem definition which is given. I hope you understand. Thank you.